Today we're going to continue talking about lines. So we're again talking about linear equations, but we're going to start talking about another form of writing a linear equation. Now, this equation that we're going to be writing is actually called point-slope. Okay, it's the point-slope form of writing an equation of a line. The issue here, in my opinion, is that this is not going to be a unique equation. Okay, this is more of a tool to get the unique equation. Okay, the unique equation of a line, the one that's going to be different for different lines, is the slope-intercept form. Because every line is going to have a different slope or a different y-intercept. Or maybe they'll have the same slope without different y-intercepts. You can tell the difference between lines by looking at the equation of the line in slope-intercept form. Okay? The issue with point-slope form is that you can have the same line have this equation look many different ways. Because they all have the same slope, but maybe you're using a different point for point-slope form. So this is more of a method or a equation to use if you're trying to write the equation of a line and you're given point and slope. Okay? If you're given the point and the slope, you can use this to write the equation and then manipulate that equation into slope-intercept form like we've been doing the last 2 days. Okay? It's just kind of a tool to get us there in the end. Something else I want you to know about point-slope form is that technically you don't have to use it. Okay? It's there. It's a tool for you. Sometimes it's going to be easier for you to use point-slope form, but you don't ever have to use it. You can always use slope-intercept form, which is why the first day I introduced it, I told you that's my preferred method of writing lines. Because if you know slope-intercept form, you can do everything you need to do with lines. Okay? So I'll explain that a little bit more here in a moment. The first thing I want to discuss here is where this point-slope equation comes from. And where it comes from is our slope equation. Okay? Our slope equation says m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now remember, the sub 2's and the sub 1's, those are just different points, right? That's why we put those there, so that x2 is different than x1, right? Okay. So there's our slope equation. All they did was first flip it around. So they said rather than m equals there, they're putting it over here. Okay, that's nothing mind-blowing. And then they're multiplying both sides by the denominator. If they multiply both sides by the denominator, it's going to cancel out over here and give us m times x2 minus x1 over there, which then gives us the equation y sub 2 minus y sub 1 equals slope times x sub 2 minus x sub 1. Yes, sir?
So would you use slope-intercept form to find the slope before you could do this one?
No. No. You would use the slope formula to find the slope. And that's why I'm saying this equation, in my opinion, is really only useful if you're actually given the slope and given another point on the line. Okay? That's really the only time I'd use this. Otherwise, I would just always use slope-intercept form. Okay? But of course, slope-intercept form, the only point that you need to know in slope-intercept form is the intercept, right? And we could do it with some other points, and I'll show that as an example as well. But that right there is where the equation comes from. Right there is point-slope form. Okay? All they did is said, well, let's get rid of the sub 2's, because remember, every equation of a line has an x and a y that stay x and y, right? So they say, okay, well, there's our x, there's our y, this is the point we know, x1 and x2, or I'm sorry, x1 and y1, and then our slope. Okay, so that's where the formula comes from. So again, if you remember that, where it comes from, then again, you don't have to remember or memorize the formula. Because if you memorize the slope formula, which we all have to, if you know the slope formula, you can very quickly get point-slope formula. Right?
Yes.
Yeah. Okay, so then let's go ahead and see how this helps us. Any questions before we do an example? No. Okay, so then let's take a look here. Writing an equation given a point and the slope. So again, this is the situation where you would want to use point-slope. Like I said, you don't have to use point slope, but this is what it's basically made for, is this type of situation. So, starting out here, I want to first just write down point slope form. So y minus y sub 1 equals m times x minus x sub 1. Now, in this equation, I need to plug in for my slope, and I need to plug in a point. And I'm plugging the point into the x1, y1. So, the point that we know is negative 5, 2. So this is x1, this is y1. And they give us the slope, so our slope is 3/5. So we go ahead and plug in. Y minus 2 equals 3/5 times x minus negative 5. Well, now all we have to do is write this in slope-intercept form. Okay? We got to write it in slope-intercept form. So, first thing I see is that minus a negative 5 is just plus 5. We have to distribute the 3/5. So we have y minus 2 equals 3/5 x. Now, what's 3/5 times 5? 3. And so then we have to add 2 to both sides. So y equals 3/5 x plus 5. Questions? Point slope form. It helps you find the equation of a line if you are given just that, a point and the slope. Okay? Why don't you guys try the next one? Find the equation of the line that passes through 7, negative 1, and has a slope of negative 3. Go. So yes, you should have gotten y equals negative 3x plus 20. Any questions on the process? Feeling good on that? Doing okay? All right. Then let's take a look here. So, here we're given 2 points. Okay? We're given 2 points. We want to write the equation of our line. Okay? Now, there are 2 methods for doing this. They say to write the equation of the line in point slope. I don't want you to do that. I always want you to write your final answers in slope-intercept form. No, slope-intercept form is y equals mx plus b. Right? Always write your final answers in slope-intercept form. Okay? But there are 2 ways of finding the equation of this line given 2 points. So, I'm going to show you both ways. The first one is point slope. The first one is point slope. So, we go through, and if we need point slope, what 2 pieces of information do we need? Well, we need a point and the slope. So, right now we have 2 points. So, we just get to pick one. Okay, so Carly, which of those 2 points do you want to use? It doesn't matter, you pick. 3, 2. So Carly wants to use 3, 2, so there's our point. But now we need to find the slope. We don't have the slope yet. We need to find it. So finding the slope means we have to use the slope formula. So we have y sub 2, which is 8, minus y sub 1, which is 2, over x sub 2, which is 5, minus x sub 1, which is 3. Well, what's 8 minus 2? And 5 minus 3? So what's our slope? Okay, so there we go. We have our point, we have our slope. We can put this into point slope form. So we have y minus y1 equals m times x minus x sub 1, and we plug in y minus 2 equals 3 times x minus 3. We've got to distribute the 3. So we have 3x minus 9, and we've got to add 2 to both sides. So y equals 3x minus 7. There's the equation of our line. Questions on the process we did here? Okay, well, the alternate method here is then using slope-intercept form. Okay, so if we use slope-intercept form, we need some information. We need what? 2 pieces of information, actually. The slope and the y-intercept. Well, at the beginning of this problem, we don't have either of those. We have 2 points. Neither of those points are the y-intercept. So that means we're going to, again, have to pick a point. We're going to need to use a point like 3, 2. I'll use the same point Carly picked for us. And again, we're going to have to find our slope. So again, we're going to have to take 8 minus 2 over 5 minus 3, and we're going to again get 3 as our answer. Okay? So we found our slope, we have a point, but if I use slope-intercept form is y equals mx plus b. What did the m stand for in slope-intercept form? Slope. What did the b stand for? The y-intercept. Here's the big question. What did x and y stand for? X and y were 2 different points? It's 1 point. It's the coordinates of a point. And remember, x and y were the coordinates of points that are on our line. Just like 3, 2. 3, 2 is a point on our line, so therefore 3 is our x, 2 is our y. And we can then go through and substitute into that. So, y is 2, m is 3, x is 3, and we don't know b. We don't know the y-intercept. But we can solve for it. 3 times 3 is 9, so I have 2 equals 9 plus b. To solve for b, I've got to subtract 9 from both sides. And we find out that negative 7 equals b. So the 2 pieces that we need for slope-intercept form is the slope, which we have, and our y-intercept, which we have. So therefore, y equals 3x minus 7. Okay? So, point slope is a handy thing to have. It's another tool in your toolbox, but it's not a necessary tool. Okay? You can get by with only using slope-intercept form, but you got to make sure you know what you're doing, because you got to find your slope just like over here, but then you also have to find your y-intercept. Okay? Then you got to use those 2 items to plug into your equation. Whereas point slope, you only have to find your slope, and then you can use that point they give you to plug in and solve for your equation. Okay? It's the same answer, you're just getting at it 2 different ways. All right? Any questions? No? Okay. Then let's talk about standard form. Standard form of a linear equation is given in the form ax plus by equals c. where A, B, and C are real numbers. A and B are not both 0. One of them could be 0, but not both. And furthermore, no fractions. Okay? No fractions. Standard form should not have fractions involved. Okay? I also personally, and I've seen this in other textbooks as well, where A is greater than or equal to 0. That means A is not negative. Okay? That is standard form. AX plus BY equals C. A, B, and C are all real numbers, no fractions. And A has to be positive. Okay? So what we want to do then is we want to take our equation there in the example right below that, y equals 3/4 x minus 5. That is currently written in slope-intercept form. We want to rewrite that so that it's written in standard form. Okay? So let's take a closer look at this example. First thing we need to do is get our x and our y on the same side of the equation. So the first thing I would do is I would subtract 3/4 x. Now, when I rewrite the left side, what variable goes first? Look at the example right above that. The x goes first. AX plus BY equals C. So the x has to go first. So I write negative 3/4 x plus y equals negative 5. All right. Well, next, we have a fraction where A is supposed to be. Multiply it by what? Oh, I can leave the 3. I just can't have the fraction. I can't have the 4 there. So I've got to get rid of the denominator. Nope, I don't need to multiply by the reciprocal. I don't need to get rid of the whole thing because that's going to give me fractions elsewhere. I want to get rid of fractions altogether. This is a process from Algebra 1 that was called eliminating the denominators. By eliminating the denominators, we have to multiply everything by the common denominator of our entire equation. Well, there's only one denominator in our equation, so we multiply everything by 4. Because if we take 4 times negative 3/4, 4 and the 4 cancel. Leaves us with negative 3. But then we also have to take 4 times y. Got to distribute that. So we have negative 3x plus 4y equals negative 20. Okay, now there was one last stipulation I gave you guys about standard form. A is always positive. So how are we going to get A to be positive? We could divide by negative 1 or we could multiply everything by negative 1. It gives us the same result. So now we have positive 3x minus 4y equals 20. There is our equation written in standard form. Questions? Yes, sir.
So you do that for every single?
When they ask you to do it. This one they asked us to write the equation in standard form.
So you always do that with standard form? So
Standard form always looks like that. Yep.
Alright.
Standard form is always AX plus BY equals C.
And you always take the denominator and then do that?
Right, because standard form has no fractions and A is always positive. Okay? Any other questions? Try another one. How about this equation? We want to write this equation in standard form. So first thing we have to do is what?
Yeah, sure.
Subtract, well, not just the x, we're subtracting 9.1x. Guys, quiet. We have to write the x first, so we have negative 9.1x plus y equals 3.6. Okay, well, in the last problem, we had to eliminate a denominator. In this problem, we have to eliminate the decimals. Again, Algebra 1 concept. We've got to multiply everything by what? 10 to eliminate the decimal. So I'm going to multiply both sides of my equation by 10. So on the left side, I've got to distribute the 10. So negative 9.1 times 10 gives me what? Negative 91. X. 10 times y is 10y. And 3.6 times 10 is 36. Okay, well the next thing is, notice that a is negative. Well, we don't want a to be negative. So we're going to either multiply or divide everything by negative 1. So 91x minus 10y equals negative 36. That is then written in standard form. Questions?
Not in this problem, but if it ever comes up, can you reduce?
You could. That would be an equivalent equation. You're saying if you could factor out a 5 from everything? Yeah, you could do that. You could do that. Okay?
So what ones is it just A that we don't want negative?
Right. A is the only one that can't be negative. Yeah, B and C, it's fine if they're negative. Okay? Any questions? No? All right. Let's stop there.